looking at the parts of the parabola. There are a lot of parts on this parabola. So everybody have their drawing down there pretty good? Not yet? Not yet? Okay, we're done. Okay. All right. Let's talk about this parabola here. There are lots of parts to the parabola. We're going to start off with the stuff that we already kind of know. And that would be that every single parabola has a vertex, right? So the vertex to a parabola is either the highest point or the lowest point. So I'll write that in. So the vertex is right there. In this case, it happens to be the lowest point. So it can either be the highest point or the lowest point. It's either one of those two things. All right? The second thing that every parabola has is called a focus. And the focus is inside the parabola. It's not outside, not behind. It's inside, somewhere inside the parabola, like the interior of the parabola. That's called the focus. And the focus plays a very important role, and we're going to sort of do some things with that later today. Okay, now, the next important piece that we build off of is the distance between the vertex and the focus. So the part that goes right inside there, we're going to define that as a distance of A. All right, it plays a role in all of the equations that we're going to use today, and it's going to be defined as the distance of A. Question, yeah? It's always right above the vertex. So, but it doesn't necessarily need to be. Oh, wait, yeah. You said axis of symmetry? Yeah. Oh, I thought you said y-axis. Yes, it always is on the axis of symmetry, which I'm getting to in just a second. Okay, if we go a units above, in this case, above the vertex, we get the focus. If we go a units in the other direction, this way, so we go negative a units, we get a line. We get a line. This line is called the directrix. Yeah, and this is a line, okay? So don't confuse the directrix, which is a line, with the focus, which is just a single point, okay? And the role of the directrix in our case, and it's a hard word, it orients the parabola. Now in this class, the parabola is only going to open up in 4 directions. In this case, it's opening up. The other 3 are down, left, and right. So it's not going to be at a tilt. You do that later in pre-calculus where you orient and rotate the axes. So in this class, all we have to do is figure out, does it open up, down, left, or right? And the directrix helps you determine that. Okay, so if the directrix was above the parabola, what would it be doing? It opening down. If the directrix was to the left of the parabola, what would the parabola be doing? Opening right. And you guys get it, okay? Every single parabola does have the axis of symmetry that we spoke about earlier, and it goes straight through the focus and the vertex. We call that the axis of symmetry. And lastly, the strangest thing that a parabola has. Okay? And here's what it is. If you go up a units, so 0, a in this case, go up a units, and you go to the left a distance of 2a units, that point is guaranteed to be on the graph. How rad is that? I know, right? I know. We've never talked about this before. And if you go up a units and you go to the right, double a units, so 2a units this way, you're guaranteed to have another point on that graph. So notice that they're all in line. So right there, they're all sort of in line. So these 2 points over here make up what's known as the lattice rectum. It's okay, just laugh about it now and get it over with. I don't know why it's called that. That's just what it's called. Okay? It's also called the width of the parabola. Okay, so those 2 points make up what we call the lattice points. So we'll just call it lattice because we don't need to write that word again. Okay? Lattice points. So, lots of stuff going on in the parabola. Let's just talk about it again, right? We have the parabola itself, which is the blue line. We have the vertex, which is the highest or lowest point. The focus, which is a units away, up from the vertex. The directrix, which is a units down. And the lattice points along with the axis of symmetry. Now, where is the vertex? It's always exactly where? Halfway between what? Yeah. No, the vertex. Where's the vertex? The focus and the directrix. I guess I see what you're saying between the lattice points, Daniel. Yeah. Also correct. Yeah. So a lot of people ask, what is the role of the directrix, right? Well, here's the quick answer to that. If you take any point on the parabola, let's say you're over here, you take some point x comma y, just some point on that parabola. If you draw the distance from that point to the focus, and then draw the distance perpendicular to the directrix, those are always the same. So if you take the collection of all of those points, you end up with the parabola. Kind of strange, right? You didn't know the parabola was so in depth with all the stuff that goes along with it. Usually we're just like, yeah, parabola, high point, low point, that's it. Opens up or down, that's it. But lots of stuff is going on here. All right, so those are all the parts of the parabola. Is everyone up to date? Question, yeah. It's A units up. Huh? I'm glad you're asking that. Let's get to that. Okay, here's what we're going to do. We're going to make a little graphing or a little chart here, okay? Box number 2 is going to be equations for parabolas where the vertex is at the origin, or 0, 0. And I told you before, it can only open one of 4 ways. So we're going to do up and down, and then the bottom we're going to do left and right. So we're making a nice little one-stopping shopping for all of the equations for a parabola centered at the origin, okay? And see that A? It's in that equation, isn't it? All right, so the first one here is going to be a parabola at the vertex, at the origin, that's opening up. Okay, the general equation that we're going to have here is given to us to use is x squared equals 4ay. So I want to call to your attention. Whenever the x is squared in both of these, okay, notice that your parabola is either going to open up or it's going to open down. In the other two equations, the y is squared. So if your parabola opens up or down, you're guaranteed that the x variable will be the squared variable. Okay. So in this case, our vertex is at 0, 0. If our parabola opens up, the focus is a point. It's a units above the vertex. Can someone tell me what that point might be then? Yes. No. 0, it's a units above. A, there you go. 0, a. Right? That's where our focus is. Okay, our directrix then, if we go in the other direction, well, yeah, but it's a line. So how do I represent the line that goes through the y-axis at negative a? What would it be? Y equals negative a. Good. That sort of just plays itself out in the problems. You'll see what I mean by that. Okay, so again, ladies and gentlemen, if our 4a value is positive, notice that we're opening up. In this case, look, our 4a value over here is negative, or the coefficients, all right? And notice that we're going to open down, so that's how you can tell. So where's the vertex here? 0, 0. So notice that in the equation, the only thing that's different is this minus sign. That minus sign gives it away, tells you that it's going to open down. The x is squared, so I know that it's going to be a down parabola. Okay, where's the focus now? If my parabola is opening down, where is the focus? Someone I haven't called on yet. Ooh, let's ask the TV. Here we go. Andrea, where is the focus? You got it. 0, a. Perfect. And what will be the equation for the directrix? Christian. Y equals positive a. Very good. Are you guys catching on to this? All right, let's do the next two a little faster. So same box. Must have known. Okay, let's continue on here. So for left, I got y squared equals negative 4ax. Notice that the y is the part that's being squared here, so you know it's going to open up to the left, all right, or right. And the fact that we have a negative coefficient is going to be left. So vertex is still at 0, 0. Okay, now let's think. If our parabola is opening to the left, where does the focus have to be? You got it. Negative a, 0. Very good. And what will the equation for the directrix be? It will be x equals a. Very good. All right, let's finish this one off here. Vertex at 0, 0. Focus is going to be, if I'm opening to the right, it's going to be at a, 0. And the directrix will be x equals negative a. All right, here we go. Let's apply all this stuff here. Let's do an example. Oh, I didn't erase this yet. Don't watch. Don't watch. You're not supposed to watch. All right, there's more. Yeah, I have to erase all that. Okay, here we go. You don't have to write the whole thing down. Just write the key words, okay? So in this example, what we're going to do is we're going to find an equation for a parabola. We know where the vertex is. They gave it to us, 0, 0. They gave us a focus at 3, 0, and we want to graph this thing. This is where the rulers come into play. So find the equation, parabola, vertex 0, 0, focus at 3, 0, graph the equation. Okay, here is how I suggest going about doing all of these conic section problems. I think it's best to start by making the graph. So give yourself an accurate graph, and please make your scale 1 to 1. Does anyone know what I mean by that? 1 to 1? What do I mean by that? Yeah, every unit is 1 unit over. Don't double them up. Don't do anything like that. Make it 1 to 1 for most of the problems, unless you're dealing with fractions. And then start dressing up the information. So I know the vertex is here. And please put a V for vertex. So I know and you know, everybody knows that that's where the vertex is. Okay, what's the other piece of information? Let's ask the TV. Esmeralda, what's the other piece of information we have? What's that? The other piece of information that we know. The focus is at 3, 0. So 1, 2, 3, 0. Please put an F there for focus. Okay, now lots of information is available to you. Can you guys see something? What do you know? It opens to the right. How do you know that? You got it. The focus is to the right of the vertex. Absolutely. So check it out. Going up here, which equation am I going to use? Up, down, left, or right? I'm going to use the right one. So I'm going to write down y squared equals 4ax. Awesome. See how that just came out? Y squared equals 4ax. Okay. Also, there's something else I know. What else? What is it? Yes? The directive. Okay. Yep. Yeah? Yeah, what is it? Yeah. You got it. So that would be right here, right? So please put a D and tell me that x equals -3, and then point to it so you definitely know what's going on. So there's my directrix. Okay, there's something else that I know that I need. Yes?
Isn't the 2A away from the focus?
Well, hold on. What's 2A? What's A?
3.
Yeah, right? Identify that A is equal to 3. The distance from the center to the focus is 3 units. Okay, great. How do I use that in my equation? Oh, check it out. There's an A right there. Whoa, yeah. So that means y squared has to be 4 times 3x, so that means y squared must be 12x. So that's the equation.
Don't we know that x is equal to -3?
No, the line x equals -3 represents the directrix. Yeah. So now I have my equation for the parabola that opens to the right with an a value of 3. Okay, how do I graph that? There's 2 easy points called the lattice points. How do I get them? Yeah, so where do I put it? Yeah, so go 1, 2, 3, 4, 5, and 6. So let's label that point. That would be 3, 6. You guys agree with that? Yes.
Can you go like another A from the focus, then go 4A out? Does that work?
No. No, because that would be linear, and parabolas aren't linear.
Oh, what?
Yeah. Okay, let's go 1, 2, 3, 4, 5, 6 down. So that would be 3, -6. And then bang, there we go. There is enough to draw my parabola, and that's kind of what we expect from you. In fact, that's exactly what we expect from you. All the information there, the right equation picked out, the work plugged in, answer box. What do you guys think?
You want to go through that? How do you get the 6?
All right, again, the best way to solve all of these problems is to start by putting all the information onto a graph. We know that the focal point is at the point 0, 4. So let's put it onto our graph. 1, 2, 3, 4. So 0, 4. I'm with you. We also know the directrix is the line y equals -4. So where is that on the grid? Is it up 4, down 4, left 4, right 4? Down 4. You got it. 1, 2, 3, 4. And the reason is because it goes through the y-axis when y is -4. Okay, there's my focus. Here's my directrix at y equals -4. All right. Now it tells me something, right? Where does the vertex have to be? Has to be at 0, 0. You got it. It's halfway between the focus and the directrix. All right, good. What is the value of A in this case? Yeah, 4 units. Agree there? Yeah, 4 units. So now I know my parabola opens upwards. So I'm going to go back over here, check the chart. According to this, up is x squared equals 4ay. So I'm going to write that down. Here we go. X squared equals 4ay. Good. What's the value of a? 4 units. So therefore, x squared has to be 4 times 4 is 16. Y, and I have found the equation. That's the easy part. All right? Now, I need to graph my parabola. The only thing I need are the lattice points. So if I go up 4 units, then I got to go out 8 units. 1, 2, 3, 4, 5, 6, 7, 8. That's double the a value. And to the left, 1, 2, 3, 4, 5, 6, 7, 8. To the left there. Drawing my parabola. All right, there you go. What do you guys think? Easy, medium, or hard for that one? Easy. So just like before, what we want to do, the best way to start all these out is to just start by putting all the information on the graph.
You never know how big the graph is.
Yeah, just go a reasonable amount. Yeah.
Squares are so much bigger than that.
Oh, I'm so sorry. So the vertex is at -2, 3. So go -2 up 3. There's our vertex. Okay, so far, I don't know if this thing opens up, down, left, or right. I need some more information. Focus says I'm at 0, 3. So there's my focal point. All right, now I've got enough information, don't I? So which way is this opening? Up, down, left, or right? This thing's open to the right. Opens to the right. Yeah. So that means my directrix is here, isn't it? So that's the directrix, and that's the equation x or y, you guys? X equals what? Nope. -4. So my equation for the directrix is x equals -4. A has a value of 2. So which equation am I going to use to write down? I'm going to say 4a times x minus h equals y minus k quantity squared. Now, how did I know that the y was squared? Because it opens to the right. And so, and then my a value should be what? My 4a value should be a positive or negative number? It should be positive because it's opening to the positive numbers. Okay, so I know now that my a value is a value of 2, right? So I can plug this in and say 4 times 2, x minus h equals y minus k all squared. So that means 8 times x minus something equals y minus something and then squared. Now the question is, it's not zeros anymore. If they were just zeros, then it'd be done and I'd have my equation. But they're not. They're h and k's. So does anyone see the value for h and k anywhere on the plane? Yes.
-2 and 3.
Yes, this represents the h and this represents the k. You got it. You got it. You got it. So this says x minus -2. And then y minus a 3. So my equation that represents this graph is going to be as follows. 8 times x plus 2 equals y minus 3 quantity all squared. Yeah, there's my equation. What do you guys think? It's the same exact thing as before, except you just use the center is somewhere else, right? The vertex is somewhere else. Okay, all I gotta do now is write down those lattice points and I'm done. So since a is 2 units, I'm going to go 2 to the right and then go 4 up. 1, 2, 3, and 4. And then 1, 2, 3, and 4 down. And then there's my graph. And I label those points at 0, 7 and 0, -1. And that's it. Keep confidence boosting at all. Okay. Hey, take a look at that. Tell me what's wrong with it. It's the wrong what? Yeah, wrong form. I didn't hear you say. Yeah, wrong form. This is standard form. Yeah, the other one's vertex form. Yeah, this is not in the right form. We can't find where the vertex is. Wait, do you know if this opens up, down, left, or right? No. You can have a 50-50 shot by knowing one thing. Yeah. The x squared looks positive, right? So it's either going to be up or down, and we're probably betting it's going to be up, right? So how do we get this into the form that we want? I gave you the answer on the left there. You guys see it? You have to complete the square on the x term, which in this case is the x. Or complete the square on the squared term, which in this case is the x. Okay, so here's how you do it. You guys remember how to complete the square? Yeah, ooh. Okay, here we go. X squared plus 4x plus something has to equal 4y plus something over there. Remember that magic number thing? The magic number. Oh, yeah, yes, it is 4. And how do you get that again, just to remind all the folks at home? Yeah, half of 4. It's just 2. 2 squared is 4. Good. Somebody tell me, what does this part break down to? Ooh. The most important thing. What is it? Yes, x plus 2 quantity squared equals, now watch this cool trick. Someone tell me, what did I just do? I factored out 4. Why would I do that? Because, yeah, someone tell me, hey, where's the vertex? Where's the vertex? No. H comma k, remember? -2 comma -1. Why are the signs switched? Because in the original formula they are minus signs. Very good. Now here's the next question for you. What is the value of a in this case? No. 1. Yes. Why is a value of 1? Yeah, because what you do is you look at the coefficients over here in front of the y term, and you say a. So that has to be, so I know 4 is equal to 4a. So therefore, dividing by 4, a has to be 1. All right, so you're going to run across a few of those, change it, and then you'll be able to graph it. That's where we find the value of a, because in the equation up here, right? This is the stuff that we were working with. Okay. All right, there you go, guys.